Welcome to the DIY Honda Garage channel. The purpose of this presentation is to discuss DTC codes P0111 and P011B, which indicate an IAT, intake air temperature sensor circuit range/performance problem in the Honda Fit models produced between 2015 and 2020. The IAT sensor plays a vital role in engine management by providing critical information about the temperature of the air entering the engine. If this data is inaccurate, it can lead to performance issues, decreased fuel efficiency, and increased emissions. The IAT sensor is located alongside the MAF, mass airflow sensor, usually near the intake manifold, where it can accurately assess the air temperature. A problem with this sensor or its circuit may cause the onboard diagnostics to trigger these DTCs. In preparing to troubleshoot, it's essential to refer to any general troubleshooting information provided in other documentation or resources related to this issue. Thorough understanding is crucial in successfully addressing the fault. The DTCs P0111 and P011B signify an issue with the intake air temperature IAT sensor circuit. The IAT sensor functions by measuring the temperature of the air entering the engine, which is essential for the engine control module ECM to adjust fuel delivery and ignition timing accordingly. It is typically located near the mass airflow MAF sensor within the intake manifold area. A malfunctioning IAT sensor can impact engine performance by causing the fuel-air mixture to be incorrect, leading to inefficient combustion, decreased fuel economy, and increased hazardous emissions. If the circuit is faulty or reading incorrectly, immediate attention is required to prevent further engine complications. At this point, assessing the IAT sensor circuit for proper function and connections is crucial. The possible causes of DTCs P0111 and P011B include poor electrical connections, a faulty IAT sensor, or deteriorated wiring within the sensor circuit. Poor connections at the MAF sensor/IAT sensor and ECT, engine coolant temperature sensors, can lead to erratic readings or loss of signal to the engine control module, ECM. A faulty IAT sensor itself can fail due to internal breakdowns or poor calibration, resulting in inaccurate temperature readings. Additionally, deteriorated or damaged wiring can introduce resistance or short circuits, leading to performance issues. Diagnosing the root cause is critical in accurately rectifying the issue and preventing further complications in engine management systems. Symptoms associated with DTCs P0111 and P011B include poor engine performance, increased fuel consumption, and the illumination of the check engine light. A malfunctioning IAT sensor may lead the engine to improperly adjust fuel injection and ignition timing, resulting in lackluster engine response. This, in turn, can result in an inefficient combustion process, causing excessive fuel consumption and possible misfires. The most immediate indicator that something is wrong would be the check engine light illuminating on the dashboard, alerting the driver to a potential issue needing attention. Addressing these symptoms promptly is critical in avoiding prolonged engine distress or damage. The first troubleshooting step involves a visual inspection of the connectors associated with the MAF sensor, IAT sensor, and both ECT sensors. Ensuring that all connections are secure and terminals are not corroded is essential in identifying potential points of failure. Loose connections can lead to intermittent signals being sent to the engine control module, ECM, causing the DTCs to trigger. If the visual inspection reveals issues with these connections, repair or reseat them before proceeding to the next step. If connections appear in good working order, it's crucial to continue troubleshooting as the issue may reside within the sensors themselves or the wiring. In this step, we will perform an IAT sensor performance check focusing on low temperatures. First, disconnect the MAF sensor/IAT sensor 1 by removing its 5P connector. Next, let the sensor cool down to the ambient temperature and record this temperature for reference. Afterwards, reconnect the sensor while ensuring it is not installed. Turn on the vehicle to on mode and use the HDS Honda Diagnostics System to read the value of IAT sensor 1. Comparing this value against the ambient temperature is critical. If the IAT sensor reading deviates by 5.4 degrees Fahrenheit or 3 degrees Celsius or more, it indicates that the sensor is faulty and requires replacement. Should the values match closely, you will proceed to the next troubleshooting step. The third troubleshooting step focuses on checking the IAT sensor's performance under high temperature conditions. Begin by ensuring the vehicle is off. Then disconnect the MAF sensor IAT sensor 1 connector again. Carefully introduce hot air to the sensor using a heat gun, applying heat for no longer than a few seconds to prevent any damage to the sensor. Once this is complete, reconnect the sensor. Check the reading on the IAT sensor 1 using the HDS. If the reading increases by 76 degrees Fahrenheit or 42 degrees Celsius or more, it suggests that there may be an intermittent failure. In this case, check for any poor connections or loose terminals at the MAF sensor, IAT sensor, and the powertrain control module, PCM. If the sensor does not respond with the expected increase, it indicates the need for replacement. After completing the repairs, the final step involves verification of the repair effectiveness. Start by clearing any stored DTCs from the system to reset the check engine light. Following this, it is essential to conduct a test drive under various driving conditions to ensure that the IAT sensor and associated components function as expected. Monitor the vehicle's performance for any returning symptoms or check engine light illumination. If the vehicle operates smoothly, without recurrence of the DTCs, the repairs can be considered successful. Should any issues persist, it may warrant rechecking the connections or considering further diagnostics as necessary. To proactively prevent issues like DTCs P0111 and P011B, regular inspections of the IAT and MAF sensors along with their respective connectors is advised. Corrosion or contaminants on connectors can lead to loss of signal, resulting in erroneous readings and potential engine performance issues. Additionally, ensuring that the intake system is clean and free of obstructions can enhance airflow and sensor performance. Scheduling routine maintenance checks makes it easier to spot early signs of wear and prevent more severe issues down the line. Lastly, ensuring that the entire air intake system is adequately sealed and operational will aid in maximizing engine efficiency and lifespan. In conclusion, addressing DTC's P0111 and P011B involves identifying the root cause of the IAT sensor circuit issues, which may manifest through various engine performance symptoms. Regular inspections of both the sensor and its connections can significantly reduce the likelihood of triggering these DTCs. Additionally, utilizing diagnostic tools such as the HDS to analyze sensor performance is crucial to ensuring accurate readings and proper engine function. Preventive maintenance is just as important, as it helps in mitigating future problems. Finally, keeping a close watch on vehicle performance and being proactive about maintenance can lead to a more reliable and efficient engine in Honda Fit models from 2015 to 2020. Please like and subscribe to the channel. See you next time!